This is for year 11 methods. We're going to look at question 7 from exercise 2F. So this question you can do completely on the calculator, but you do have to show, at least some working steps so I know what, your line of thought is, so that on a test or SAC, I can actually give you marks for, in case you get the answer wrong, but you've got the right thinking. So part A is find the x-intercept of the line in terms of A. You can see we've got an equation here. So as we know, x-intercept, you sub in y equals 0 and you solve for x. Okay, so you just got to enter that whole equation on your calculator. So let's do it. All right, so we've got, I'm going to use the fraction button, x divided by a. Now you can use different variables if you want. For convenience, I'll just stick with the variables that are in the question. So y divided by 12 equals 4. Okay, so what we're going to do is we're going to sub in y equals 0, because x-intercept we know y equals 0, so we're going to go given y equals 0, and you're going to solve for x. So what this does is subbing in y equals 0, and then you're solving for x, because you want the x-intercept. And the x-intercept happens to be 4a. So part 1 would be x equals 4a. So your x-intercept would be in coordinate form 4a 0. Okay, that's your final answer. Part B, it says find the gradient of the line in terms of a. Again, we can do this on the calculator. We want to find the gradient in terms of a. So that's pretty straightforward. All you need to do is, I've got the equation here. I've just copy and pasted it just for convenience, so I don't need to type it again. I'm going to go interactive advanced solve. I want it in y equals mx plus c form. Why do I want that? Because I know that in y equals mx plus c form, I can read what the gradient is, because the gradient is always the coefficient in front of the x in that form. So I'm going to make y the subject, and I get 12xa minus 48, so y equals, so when I rearrange it, I get y equals 12x on a minus 48. As we can see, my gradient, the number in front of the x, would be 12 over a. So that's my gradient. Part C, find the value of a if the gradient is 2 and negative 2. Okay, so part B and C are actually related. When it says find the value of a when the gradient, you notice how we found the gradient in B in terms of a? Okay. Now for part C, it's simply stating that the gradient is equal to a certain value. So we know the gradient is 12 over a. For part 1, 12 over a happens to equal 2. For part 2, 12 over a happens to equal negative 2. And you just solve it on the CAS calculator. So you literally go, you can do it by hand, but like I said, I do want everyone to be comfortable using CAS calculator. So 12 divided by a, I'm going to be lazy, I'm just going to use x because we've only got one variable, equals 2. Interactive advanced solve for x. So a equals 6, and I'm going to recycle this because I'm adding a negative 2 here. 6 and negative 6. So a equals 6, a equals negative 6. So as you can see, you can comfortably do all three parts of the question using the CAS calculator. So hopefully that helps.